Hello, everyone. Let's wait for 2 minutes to all the participants to arrive, okay? See you in a couple minutes. Hello, good morning, everyone. Welcome to the webinar on Anastrepha ludens of the Group 1 Fruit Flies EU Priority Pest. Let me share with you the presentation. Hold on a second. Okay. Hello, everyone, again. I hope you're seeing the presentation right now. My name is Jose Ovejas, and I will be the moderator of this webinar today. As I said, it is the webinar on Anastrepha ludens of the Group 1 Fruit Flies EU Priority Pests. As I see today, we are more than 200 participants. Thank you very much all to attend this webinar. As you might know, we previously provided 3 webinars on the EFSA plant per survey methodological framework and the toolkit, including the RePest and the OptiPest. If you did not attend the previous webinars and you would like to know more about them, the recorded presentations are available on EFSA's YouTube channel and on the EU Academy website. If you did not attend, no, sorry. This is the first webinar of a round of 4 that will take place before the summer break, and today's presentation will refer especially to the pest Anastrepha ludens. Lastly, for the new attendees, and as a reminder, since the microphones are mute, the Q&A chat is enabled for you to ask any questions that may come up while the experts are presenting. Now you are automatically connect to the audio broadcast, one-way audio, just listen mode, and the event is in English. The questions should be as well submitted in English via the Q&A chat. If you have some questions remain unanswered, you can always send them by email. This event is being recorded, and recordings will be published in the YouTube channel and in the EU Academy website. We will send all the information after this webinar. Well, after this event, attendees will be requested to evaluate the EFSA's event, filling out the Zoom survey. Okay, for today, the agenda, as you can see, is gonna be, we are now in the small presentation, in the small introduction, and then we will give the word to the 2 experts that are with us today. So we have today Stephen Parnell, and we have also Nikos Papadopoulos. After this presentation, we will have a short quiz, and then in about 1 hour, it will be the end of the webinar. So, as I say, my name is Jose Ovejas. I'm a journalist, and I will be the moderator. And today we have the first expert is Stephen Parnell. He is from the EFSA Pest Survey Methods Working Group on Plant Disease, an epidemiologist from the University of Warwick. And we have as well Nikos Papadopoulos. He's from the EFSA Pest Survey Methodologic Disease Methods Working Group, and he's a PhD professor of applied entomology at the University of Thessaly. Okay, for the poll, for the quiz that we are gonna have, we are gonna use the Mentimeter, okay? So we would like to invite you all to participate in the poll. So to recognize who is in the room, please, you have to proceed to search www.menti.com with your mobile phone or laptop. You can also scan the QR that you have in the screen, and then you will have to enter the code that will be displayed in your screen in a few seconds and click the join button. I leave you a couple seconds so you can scan the QR or just type www.menti.com. Okay. Before we begin the poll, I would like to stress that Mentimeter will be also used at the end of the webinar to display several questions that the experts have prepared to check the understanding of the participants of the contents of this webinar. Therefore, it is advisable for you to keep this in mind and have an electronic device nearby to expedite the process. Okay, I see you are already participating. Okay. Okay, I'll give you some seconds because maybe you're just trying to use the Mentimeter for first time. As I can see at the moment, we have most of the participants comes from National Plant Protection Organization. Okay, we have already 130 participants already answered the survey. One hundred 40 participants already answered this. And as I said, most of them are from the National Plant Protection Organization, and we also have some support laboratory diagnostics. Okay, it's important you to learn how to use Mentimeter because we will use it at the end of the presentation. So you can do a little quiz. So for us to understand that you learn a little bit about the presentations that Nikos and Stephen has for us today. Okay. So before we go to the presentations, let's continue with a brief video before I give the floor to Stephen and Nikos.
Health. The European Food Safety Authority is the reference body for risk assessment of food and feed in the European Union, and its work covers the entire food chain, from field to fork. The target audience of this initiative is both in the 27 European member states and the third countries. The inspection services of national, regional, or local authorities competent for the planning and execution of the pest surveillance, the services that support the inspection with laboratory diagnostics, the risk managers that are involved in decisions related to the planning of surveillance activities, and manage the contingency plans for crisis preparedness in case of outbreaks of regulated pests. 3 webinars have already been provided. Webinar 1 on the Plant Pest Survey Methodological Framework, Webinar 2 on the Pest Survey Toolkit, RIPEST, Webinar 3 on the Multi-Pest Survey Optimization, OptiPest. The recordings are available in the EFSA official YouTube channel and in the EU Academy platform. Starting from March 2025, we are providing specific webinars for the preparation and design of detection surveys for the 20 EU priority pests that are listed in the annex of the Commission Delegated Regulation 1702 of 2019 and a specific e-learning course that will provide the participant with an overview of the methodology for preparing, designing, implementing, and reporting of surveys of union quarantine pests using the tools developed by EFSA. The e-learning course will be available online, and individual modules won't require the user's attention for more than 30 minutes. The course will be interactive and consider a good balance between theory and practical exercises, as well as a final certificate of attendance at the finalization of all modules. After participation, any attendant will be able to prepare, design, execute, and conclude the detection, delimiting, and buffer zone surveys using the methodological framework and tools developed by EFSA. Send your application or contact us to receive more information to
Thank you, everyone. Sorry for these technical problems. As I see now, we're over 300 participants. Now is the moment for me to give the floor to our two experts. So the floor is yours, Nikos and Stephen.
Okay, thank you very much, Jose. And good morning, everybody. Welcome to this webinar. So I start with a quick overview. So this is the structure of today's presentation. We start with the biology of the pest, the distribution, some general information for Anastrepha ludens. Then we present the EFSA methodological framework for survey design, and we go to specific applications for the Anastrepha ludens that include the epidemiological units, inspection, detection, risk factor, design prevalence, and at the end, we demonstrate the ripest for Anastrepha ludens. So if we go to the next slide, we start with the Anastrepha ludens. As you can see, this is the fly. It's a relatively large fly compared to other tephritids, and the females have a peculiar way of ovipositing. They U-turn the abdomen, and the ovipositor, as is shown in the picture. The species overall is a clearly defined taxonomic entity. So Anastrepha is a multi-voltine. If we go to next slide, Stephen, yeah, Anastrepha is a multi-voltine species that poses an imminent threat for fruit production in North America. Similar to other fruit flies of tropical origin, females oviposit a batch of eggs into the peel or flesh of ripe or ripening fruits, and maggots feed in fruit flesh before dropping to ground to pupate. It is detected every year in Texas, in the United States of America, frequently in California, and occasionally in Florida. However, it has never been found out of North America. So there are 2 to 3 generations per year, as you can see, but this depends largely on environmental conditions. We can go to next. If we go to the hosts, there is a long list of hosts for the Mex fly, as it's the common name of this pest, including mainly citrus. You see the Rutaceae family and a lot of citrus fruits, pome and stone fruits as well. And there are several fruits of tropical and subtropical origin that can be infested by this pest.
Nikos, sorry, can I just ask, so what would be the most important host for the EU, would you say?
I would say, and as we show later, Stephen, that this is a pest that goes to warmer areas. So citrus would be the main crop affected, different citrus species, as well as some stone fruits like peaches might be affected. Right. The economic importance. Now, there are various estimates that indicate 100 millions of US dollars per year. That may reach almost 1.5 billion dollars in 5 years. In 5 years, we can have a loss of 1.5 billions. So that's actually a very important pest.
So is that economic impact that's been predicted to happen in the EU, or what sort of impact has happened in other parts of the world?
This is mainly in the Americas. The estimates are from there, but in Europe, as I said, we expect to have impact in the southern European countries, and especially in the crops that I mentioned earlier, like citrus and peaches, probably. So, as you can see in the current table, depending on temperature, the duration of the developmental stages may vary a great deal, with eggs lasting from few days to almost a month, as you can see in the table. Larvae from a couple of weeks to almost 2 months, and pupae for few weeks to more than 3 months. Similar, it's the adult longevity. It varies a lot depending on the conditions, and for both males and females can exceed several months, up to 3 months, 4 months. In extreme cases, we might have more than this. Females oviposit from few hundred to more than 1,000 eggs in lifetime. So the population can grow quite fast considering all these demographic elements of the life cycle.
So there's a lot of information available on the pest. So is this in the pest EFSA pest survey cards?
Yes, indeed. In fact, there is a lot of work that has been done over the last few years, and they are well summarized in the EFSA pest survey cards. So the geographic distribution now, this is, you see, there is a narrow geographic distribution originated from the southern parts of North America. The fly as confined, I would say, there. So we can have detections, and the fly is established in Texas, in southern Texas. And the distribution covers the area from Panama to Mexico, and as I said, southern United States. Interestingly, the fly has never been reported out of this area and never has been detected in Europe. So the climatic suitability, though, EFSA has also worked on defining the bioclimatic suitability for this pest. And as you can see in this slide, looking on the left side panel, it's the number of generations that the pest can conclude in Europe. As such, you can see, can barely develop a generation in Central and Northern European countries, but in the coastal area of the Southern Mediterranean countries and in Portugal, we can go up to 3 and 4 generations. So these are the places that we expect to be established if it arrives. And in the middle panel, we have the temperature in Europe, which is the main limiting factor for the establishment of this pest, and then the estimates of the countries that will be affected by this pest in Europe on the right-hand side panel.
So I guess not all member states would need to conduct a survey for this pest. I think Finland is probably okay, but which member states do you think it would be relevant?
Yeah, that's a very good point and relevant, Stephen. Yeah, the data and all these estimates indicate and show that Southern European countries are the countries that will be affected, and we need to have more than 2-3 generations per year in order to have a sustainable population. So I suppose Spain, Italy, Greece, Cyprus, Malta, even the coastal area of Adriatic Sea, Croatia, should establish a detection network. But we have also always climate change that might change things in the near future. So northern areas might be affected, but this is another discussion. So, all right, looking a little bit at the dispersion capacity, this is a strong flyer, capable of dispersing in long distances. And this is indicated by both empirical data of release recapture studies, but also for some modeling. So in extreme cases, we have recaptures in 135 kilometers, but it's possible to estimate that few kilometers can be covered in a year. So we estimate, based on the expert knowledge elicitation, that 6 kilometers per year would be the maximum dispersion distance for this pest. And this is an important parameter that will be used later.
But I guess longer range spread might be possible by humans. Is this included in this number, or?
No, this does not include the human assistant travel, the long distance travel. It's just the capacity of the pest to disperse. Yeah, thanks, Stephen.
Okay, so as Nikos has shown, it's not a pest that's not present in Europe currently, but there is establishment in some of these areas, at least. So the type of survey that we'd want to conduct, the EFSA framework includes different types, but it would be a detection survey in this case because it's currently free. So next in the webinar, I'm going to sort of explain this EFSA methodological framework for survey design, and we're going to sort of talk through this and how we might apply this to Anastrepha ludens. So to start with, well, why do we need a methodological framework for survey design in the first place? And I think it's two main reasons, really. The first is that it allows us to design a survey in a way that is statistically sound. So why do we need statistics? Well, we can think of our host population a bit like an iceberg, in that the survey can only access the tip of the iceberg, and the rest of the host population is hidden. So if we can only survey the kind of tip of the iceberg, what we want to know then is how confident can we be that the rest of the population, so this population that we can't survey, is also pest-free. So this requires statistics. And then secondly, the framework allows us, so it's risk-based. So in other words, it allows us to incorporate information on when and where the pests might occur. And ultimately, because we have this intelligence and this information, we can use that to reduce the number of inspections that are required, sorry. So the framework relies upon structuring our
Steven?
target population. Sorry, Nikos.
Okay, I had a question. Sorry for
Okay, sorry, go on.
back. I like this example with the iceberg. Can you explain a bit more on the hidden part of the population? Because this is a really interesting point.
Yeah, of course, yeah. So imagine, I don't know, imagine in your survey area you had 100,000 hectares of citrus. It might be that you can only survey like 10% of that. So what that means is there's potentially 90% or 90,000 hectares of citrus which you can't survey. So what you're forced to do is the 10% that you can survey, if you don't find it there, you have to then make a conclusion about the rest of the population that you think that is also pest-free. And then generally, the smaller the hidden part relative to the bit that you did survey, the more confident you would be. And what the framework does is allow us to the statistics sort of allow us to conclude on that, basically.
Thanks, Stephen.
So when we're using the framework, what we tend to do is to split the survey area into these different levels, and what we're going to do is to talk through each of these individually. The first is obviously your survey area, so that would usually be your member state or the part of the member state where you're interested in conducting a survey. But the next is the epidemiological unit. So this is a kind of homogeneous area where the interactions between the pest, the host plants, the abiotic and biotic conditions would result in effectively the same epidemiology. So this is the first sort of choice we have to make about the pest. So I don't know if I pass back to you, Nikos, what would this look like for Anastrepha ludens?
I think for this specific pest, the epidemiological unit should be a citrus, also a stone fruit orchard in the southern in areas of southern European. So the slide shows actually a typical landscape of citrus growing area. And this regards an island in Greece, the Chios Island, but it's quite typical for other Mediterranean countries, where citrus orchards on the left should be selected for the survey. And you see also a traditional citrus orchard on the right, a smaller picture. However, Stephen, defining the inspection unit is an important element for the whole process. That's
Yeah, I think so. Maybe if we go to that next, the inspection unit, like you say, it's really important because it's the kind of elementary unit. It's the smallest unit that we have that the survey is focused on, and it's the unit at which we apply the detection method as part of the survey. So the inspection units define the subdivisions of the target population. They're how we measure the size of the target population in terms of how many units, as well as the sample size, how many inspection units we're going to look at. So yeah, these are really important. And in general, just for all pests, there's different ways of thinking about this. It depends a bit on the pest, it depends a bit on the detection method that you're using. But for example, the inspection unit might be an individual tree. It could be smaller scale than that. It could be like the individual fruit on the tree. Or if you are looking at an insect, like what we are in this case, it could be the area covered by a trap, or in some cases, it might even be the pest itself. So we have to think a little bit in our choice, depending on the pest, depending on the detection methods. So what about then for our pest today? What kind of things might we consider?
We can detect either immature stages, eggs and larvae, or adults. Apparently for eggs and larvae, we should go to fruit sampling. So we should focus on ripe or ripening fruit. And in this case, the tree bearing these fruits is the inspection unit. Apparently, infested trees revealed by visual inspection and sampling of symptomatic, mainly fruits, bearing signs of oviposition, signs of infestation. It's also important to consider fruits that have recently fallen to the ground and to consider them in the sampling. For adult traps should be considered, and here we have no specific strong attractant for this pest. So food baits are used for Anastrepha ludens. And because of this, we consider a radius of 30 meters around the trapping point as the area that can be covered. And this then is the inspection unit. So, Stephen, I think we have other interesting elements here, which is the method sensitivity. Can you elaborate on this a little bit?
Yeah, so for depending on the detection method that you choose, we have to think about the sensitivity of that detection method. So you outlined a few different ones there, but in any case, in general, the method sensitivity, it's the probability to correctly identify the pest as being present if it's there in the inspection unit. So you have your inspection unit, you apply your detection methods to it, and then it's then if the pest is present in the inspection unit, what's the probability that you will identify it? So it's not just diagnostic sensitivity in the lab, it's this whole process of everything, the whole sequence of events that happen from the field all the way to the laboratory. So in the field, it's about the sampling effectiveness. So given your inspection unit and it's present in that inspection unit, what's the probability that you'll take a sample that contains the pest? And then when you take that sample to the lab, if the pest is present in that sample, the diagnostic sensitivity tells us then, well, what's the probability we would pick it up in that sample. So yeah, for the different methods you identified, what do you think in terms of the sensitivity?
As I said that, as mentioned earlier, symptomatic ripe or ripening fruit should be inspected in each unit, in the tree. So having the tree as the inspection unit, it is estimated that let's say 20% the probability of detecting the pest with this method if the pest is on the tree, if we have infestation on the tree. So this is what we have recently estimated, actually. So.
Okay, and for trapping?
Yeah, for trapping, as we said earlier, that we consider a radius of 30 meters from the trapping spot, and the sampling effectiveness, it's a little bit higher, something like 25%, as we have estimated. Again, we have to consider that we don't have a really strong attractant for this fly. So that's the recent estimates, and this is a really difficult exercise to conduct, but it's important to have these estimates. So
this is the sampling effectiveness. So method sensitivity is sampling effectiveness multiplied by the diagnostic sensitivity. So what kind of numbers might there be for the diagnostic sensitivity?
I think we can have high levels of diagnostic sensitivity, more than 95% probably, because we do have keys to identify it's easy to distinguish the genus, the Anastrepha, from other fruit flies. But then within Anastrepha, we need to elaborate a little bit more on the morphological characters of the aculeus and the ovipositor. These are the important things, but there are keys out there. And also there are molecular markers that can be used. So I think this is quite high, then the diagnostic sensitivity would be quite high.
Okay. Well, the next thing that we'd sort of want to think about, so we talked about the epidemiological unit, we've talked about the inspection units and the associated detection methods. I mentioned earlier that we can also incorporate risk factors, so things that tell us something about where and when the pests might occur. So a risk factor is any biotic or abiotic factor that increases the probability of the infestation. And what it allows us to do is, because we've got more information, we know where to look, we can use that to effectively reduce the total number of inspection units that we need to look at. And when we're thinking about risk factors, it's useful to think about different aspects of them. So the first is the activity. So what's the actual activity that's leading to this increased chance of the pest occurring? So that's the kind of risk activity. Then we'd want to know, well, where is that activity occurring? So there may be a number of locations within your survey area where this activity is occurring. You would want to map them and know where they are, so you can target them. And then finally, this sort of risk area. So around the risk locations, you'd expect that there might be also an elevated chance of the pest being present.
So, Stephen, may I ask something? Actually, risk activity and risk locations are kind of easy to understand and to grasp. However, defining the risk area within the epidemiological unit would be more challenging. So what are the criteria that can be used for defining the risk area?
Yeah, so essentially the information that we have on the spread rate. So if it was a year since the last survey, we might consider that the pest could have had a chance at maximum to spread its annual spread rate from the location. So we can use that information that we've got, that data on the spread ability of the pest to define this risk area. So yeah, that's how we use it, basically the information on the spread. But we've got to think about the other things we have to think about is that a risk factor might have multiple levels. So within that area around a risk location, we might expect, well, nearer to the risk location there to be a higher elevated risk compared to slightly further away. And then we also have to think about, well, within our target population, what proportion of the area, the total area, is within this risk area and what is in the baseline in the rest of the target population. And then finally, we need to think about something called the relative risk. So for each risk level that we define, we need to know its relative risk. So the risk factors and the risk activities and locations, these tell us something about the nature of the risk. But to incorporate it within our framework, we need to know, well, how risky is it? So the relative risk tells us the risk of the pest being present in the high risk group relative to the other groups. So what sort of risk factors might we consider for the pest? Nikos, if you could talk us through them.
Yeah, definitely analyzing risk. First, we have the risk activities, and I would concentrate actually on the import of fruits from countries where the pest is present. I think this is the main risk activity. So as risk location, considering this activity, we have the entry points, packing and sorting stations, and also processing industries. And then the area around this risk location is the risk area. So as you said earlier, we classify this as a high risk area, but we might have, other levels as well. So
okay, but then if we look at this one, you've kind of so far you've classified the relative risk as high, high, medium, low, but we'd need to come up with a sort of number for this. So the way, there's different ways you can think about that, but just to give a kind of example, it might be from observations that you've made. There were 12 incursions of a pest, and let's say 9 of them had occurred around the risk location in the risk area and 3 in the baseline population. So we'd just say 9 divided by 3, the relative risk then would be 3 times more likely to occur in our risk area in this example than in the rest of the population. So we really need sort of like numbers or estimates of the relative risk for our risk areas if we're going to use them in the framework. So for Anastrepha,
Yeah, actually, considering as we mentioned earlier, the entry point, then, in the risk location, we can specify 2 risk areas of high and then we say of medium relative risk. The first is very close to the location. It is a radius of 2 kilometers from the risk location. And the second, it's a band from kilometer 2 to 6. So the relative risk has been estimated to be 1.9 and 1.25 for the first and the second risk areas respectively. So, and this is compared to a baseline population, so the population in the broader area.
okay, great. Okay, so we have our been through these different elements that we need. We're going to give an example now from Surveyland. So that will be our survey area and our epidemiological unit. We're thinking about citrus orchards. We're thinking about our risk areas around these entry locations that Nikos just described. And then we'll use for our inspection units a trap, so the area around the trap in this case.
So we have everything now. So
Yes.
how we put all this information in the IPEST. So
Yeah, so we'll use this hypothetical example. So we don't like to use like one particular member state, but we have we have created a country, a nation for the purpose of this webinar. This is Surveyland. So you can actually select this in RIPEST, so it allows you to kind of to play around with it and to use a sort of exact toy example. But our inspection units there, the area covered by a trap. So this is a 100, this was 30 meters, I think, so or 0.3 of a hectare. We're going to say that in our target, in Surveyland, there are 100,000 of these inspection units, so 30,000 hectares of citrus. As you described, the sampling effectiveness of the traps was this was elicited during that expert knowledge elicitation from EFSA as being 25%. You described that the diagnostic sensitivity that we'd expect this to be high, so we can use 95%, and we have our different risk levels where we've quantified our relative risk. So 1.9 in that initial band around the risk location, 1.25 around that 4 to 6 kilometer band. But before we can start, there's one other thing that we have forgotten about, and this is the design prevalence. So I'll just talk through that quickly.
Evan, can you go a little bit back? Actually, I have a question, or I may
Of
have
course.
missed something. So, can you explain a bit more how this 5% and 6% proportion of the target population is estimated?
Yeah, so for Surveyland, I created
Yeah.
this figure, but you could calculate it because we know that it's 6 kilometers around the entry location, so the risk location. So if you know how many of these risk locations are, you can calculate for your member state what proportion that represents. But just for the sake of argument here, we'll just use 5 and 6%.
Good, good.
So for the design prevalence, now this is the provides us with the level of evidence that we have in pest freedom. So it's the maximum prevalence that the pest could have reached, but we'd expect it to go undetected by the survey. Now setting the design prevalence, or the DP, is a sort of risk management decision. And that's because it's a trade-off. So, right, the lower the design prevalence you use, the stronger the evidence that you have for the pest freedom, but the more resource that would take. So it's a bit of a balance. And you can see that in this graph here. So here for different design prevalences, 0.5%, 1%, and 5% of the total target population, you can see how you would have to take an increasing number of samples or inspection units that you would need to look at to get a high confidence level there. So one useful way to think about the design prevalence, so if we're thinking what value should we set it at, one useful way is to think about, well, what is the maximum prevalence that the pest could reach in your survey area and still be eradicable? So what might that look like for Anastrepha ludens, Nikos?
I think the maximum radius for Anastrepha ludens that can, if we have an outbreak that can still be eradicated is around 1 kilometer. So in the scenario, we should consider that the pest has been detected and the area is delimited. And then we have the full package of the eradication protocol that can be applied. So that here in this specific pest, we should consider chemical treatments, bait applications, and also combined with phytosanitary measures on removing infested fruits with symptoms from a specific area. Also, a package of sterile insect release package is available. There are tools out there to be used.
Okay, great. So we can use that then. So if a 1 kilometer radius is about 314 hectares. So in our case, we said there were 30,000 hectares in Surveyland. So that is approximately about 1%. So that's what we can use for the design prevalence. So now we really do have everything we need. So finally, we can just move to rye pest, and I can show how we might implement this in the rye pest tool quickly. So first of all, this is what rye pest will look like. We have the introduction phase. The first thing we need to specify is what is the goal, and we can say it's to comply with regulatory requirements. The pest, of course, it's Anastrepha ludens. It's absent in Surveyland, thankfully, and no survey has been conducted in the past, we'll say, for this scenario. Here is Surveyland. If you haven't been, it's in the middle of the Indian Ocean. For simplicity, we'll say that we're just looking at this one citrus species. So I think this is bitter orange. And then if we continue, what's nice in repest is that you have, if you click on a word that has this light bulb next to it, you get a nice definition to remind you of the term. And we also have a link to the pest survey card where you can find more information to inform your survey design. The inspection unit, we're thinking about a trap. So this is an area, and we're just going to have one inspection unit with our 100,000, one epidemiological unit with our 100,000 inspection units. We're going to conduct a risk-based survey, which does, as we've seen, the risk will depend on the spread capacity of the pest. We're conducting it in orchards. Let's do it next month. We have to be quick though. And we'll just use the one detection method, which is our traps, which has a sampling effectiveness of 25%. And as you saw, the diagnostic sensitivity was 95%. And then if we finish this survey, then we can see rye pest is now run, and what it's done is for the different risk areas, so our high, our medium, and just our base, which is the rest of the population, it's calculated the number of samples that we would need to look at in each of those. So this is the theoretical sample size here. So 232 in this high risk area, 445 in the baseline, and so on. So our inspectors in Surveyland for this survey are going to be busy next month, I think. And then finally, it does allow you to include then because maybe what happens in practice is maybe you ended up doing slightly less or slightly more in the different areas. So it does allow you to recalculate that. But if you didn't, then you can stop there and you can download the reports. So either in this format here, so it tells us everything that we've entered into Repast, and it gives us a really nice, convenient printout PDF that captures everything that we put into the survey. And then you can also download the official report in the official format as well, with everything is there. I skipped some of the steps with the NAs, but everything will be there for you in those reports. Okay, thank you. Thank you for listening. I think that's everything from us.
Yeah, thank you very much.
Thank you, Stephen. Thank you, Nikos. Well, I'm glad to share with you that we have been almost 400 participants, so I'm happy to share it with you. I want to remind you that this is a one-way only audio webinar, so you cannot speak. If you have any questions, you can always submit them in the Q&A chat. So now we are going to do a poll. So it's a quiz. It's not an exam, so please try to participate. We are going to use again the Mentimeter. So you can enter www.menti.com, or you can use the app in the mobile, Mentimeter. You can see in the upper side of the slide the code that you have to introduce to participate in the quiz. Okay? So let's see. Let's go for the first question.
I don't think it's sharing yet, Jose.
So the first question is, what is the maximum annual spread distance of A. ludens, Anastrepha ludens? I see some of you are answering already. You're really fast. I give you 2 minutes to those ones that are maybe downloading the app or just going to www.menti.com, and you have to enter the code that you can see in the upper side of the slide. I see most of you agree. We have almost 100 participants says 6 kilometers. Okay, I'll give you a little time to answer. Don't worry, it's not an exam. It's just to understand that you just could understood the presentation that Stephen and Nikos did today. Okay, so almost all of the answers agree is 6 kilometers. We will have Stephen and Nikos after the small quiz to give you the solutions of this small quiz. Okay. $200 people already answer, around 200 people. Or no, 150. So for those maybe that don't know how to do it, I will remind you it's in www.menti.com, and you have to introduce the code that you can see in the upper side of the slide. It's 76142568. Okay, let's go for the second question. What is the diagnostic sensitivity for Anastrepha ludens? Some of you are really fast. Okay, so we have option 1 is 20%, option 2 is 25%, option 3 is 50%, and option 4 is 95%. You were really fast answering this one, and almost the majority thinks it's 95%. I leave you a few seconds to answer. Okay, so maybe we go for the next question. Okay, so the third question is, which of the below is the correct definition of relative risk? For those that don't know how to use it, I will repeat that you have to go into www.menti.com and you can introduce the code that is in the upper side of the slide is 76142568. Okay, this one is a little bit, you have to read a little bit more of the answers. It's not a percentage like the ones before, but I see most of you are answering the fourth option. Okay, I think you're almost all the ones that are participating are almost answered this question. So let's move on for the fourth question. So the fourth question is, what are the most effective type of traps for Anastrepha ludens? Option 1, bucket for magfall type traps baited with food attractants. Most of you are answering to this one. Actually, all of you are answering that one. So I'm sure you're probably is the correct one because no one answered any of the other options at the moment. Oh, yeah, we have two participants that answer sticky traps deposit in or near citrus trees. Okay. So let's move on to the fifth question, the last one. In which set of countries is Anastrepha ludens currently not confirmed? Option 1, Belize, USA, Honduras. Option 2, Mexico, El Salvador, Costa Rica. Option 3, Brazil, Chile, Argentina. Option 4, USA, Mexico, Panama. Okay, so almost all of you are answering to the third option, Brazil, Chile, and Argentina. Let's see. Okay, I think we are almost done. I give you a little time, but yeah, I think all of you are answering already. Okay, so we have here the results. So Stephen and Nikos, I give you the word if you want to explain why these are the correct answers.
Oh, Stephen, can you go?
Yes, of course. Yeah. So, what's the maximum annual spread distance for Anastrepha ludens? Yeah, this is 6 kilometers. As Nikos explained, this doesn't include those long-range human jumps, but everything without those long-range human movements. This is 6 kilometers. I think most people got that right. So well done. For the diagnostic sensitivity, yes, 95%. I think some people went for 25%, but remember that was the sampling effectiveness of the traps. The 95% was the diagnostic sensitivity. Question 3 was interesting because most people actually didn't get this right. So the answer that most people went for was actually the definition of a risk factor, but the definition of a relative risk is this elevated risk of presence of the pest compared to a baseline level. But it was a bit of a trick question because these things are all related. For question 4, Nikos, I think this is correct.
Yeah, it's the bucket McPhail trap that is usually what is used. So as we mentioned, it's food attractants, not a very strong attractant, but they are still, they can use torula yeast or ammonium acetate or other compounds there. Yeah.
Yeah, and then this final one, which set of countries is Anastrepha ludens currently not confirmed? I think everyone got this as well. It's not in South America, so it was option 3.
Okay. Thank you very much, Nikos, and thank you very much, Stephen, for your presentations. I want to thank you all for attending this webinar. We are arriving to the end of the webinar. In case we didn't manage to answer all your questions, you will find them published on the UE Academy. Please note that similar questions we will group where possible. Okay. So the recordings of today's event will be able on EFSA's website and other official EU platform, EU Academy. For the next webinar, will take place on April 29th at 10 a.m. and it will be on Bacteria dorsalis, EU priority pest group 1, fruit flies, Tephrididae. Please take a few minutes to fill out the evaluation survey that you will receive after this event. Your feedback is really essential for us to improve our future events. And well, I want to thank you all again for attending this webinar. Thank you, Stephen, and thank you, Nikos, for your presentations. We have now reached to the end of the session. I hope you all have learned about this pest and are now well informed about it. As I mentioned before in the previous slide, the next webinar is going to be scheduled for April 29th. I hope you all can attend. And as I said, if you have any further questions that have been answered for this webinar, you can always submit them by email. Thank you very much. I hope you have a nice rest of the day.